Hi, and welcome back to another video. And in this lesson, we're going to go over chapter 9.3 for two dependent sample with match pairs. Okay, so let's go ahead and get the symbols out of the way. So now you can see we're going to use a symbol with the mu, and it has a subscript of D. D stands for difference. So basically, we're going to be figuring out, these are all dependent samples, which means that one set of data relies on the other. So let's go ahead and let's just jump in and learn as we go, right? All right. So the null hypothesis H sub 0. How do we? What's the symbolic notation? Well, same old for a null hypothesis. In this course, we're going to use an equal sign. So also another thing, in this course, we're always going to use 0, and you're going to see why as we progress. So yeah, equal 0. And now the alternative hypothesis, that's the less than, greater than, or does not equal to stuff. So let's go ahead and read the passage. It says, listed in the accompanying table are numbers of hospital admissions in one region due to traffic accidents on different days. Let's keep on going. Let's test the claim that the data support that the claim that more than, okay, here's what we're looking for right here. More than, all right, don't want to waste your time. More, greater. So let's go ahead and use the greater than symbol. We're gonna put 0, and give me 1 second. That the claim one. Okay, let's go ahead. All right, and we got it. Yeah, so look for those keywords. It's a continuation of the previous chapters. You know, get a feel for the subject matter. Another thing to note, we have Friday the 6th and Friday the 13th. The 6th comes before the 13th, right? So basically whatever happens on that day, we're actually comparing the two. So yeah, these are definitely dependent samples. If you remember from the last video for 9.2, we were trying to see if they were independent or dependent or not. Dates are dependent upon each other. So if something happened on one date, on a later date, they are related. And yeah, let's go ahead and keep going. Okay, so take a look at this one. We need the symbolic notation. The answer is less than, so let's see if they use the word less than or something like that. Something key. Or we're talking about males and females. It says listed below are the number of words spoken in a day by each member of 8 different randomly selected couples. All right, so these are couples. So yeah, they are dependent upon each other. Anyway, use a 0.05 sig level to test the claim that among couples, males speak fewer words in any day than females. Okay, let's see. In this example, all right, mu d stands for the mean of the differences. Let's see. Okay, so it's like what is our first set of data and what is our second? The category, you see the first row has males in it and the second row has females. These are couples, so one depends on the other. If they're having conversations with each other, they're dependent on one another. Can you imagine someone flapping their gums and the other one is just sitting there and listening? To me, that's a toxic relationship. Both should either not say anything or both should either speak and, converse. If one is speaking, the other should be, giving some feedback. But that's just me. I'm not a love guru. Anyway, okay, so they want you to put the symbolic notation according to males speaking fewer words than females. The males came first and then the females second. As you can see, the males are speaking compared to the females are speaking. Oh, there's a chatter box right there. The females are speaking. Looks like it's a little bit. Oh no, never mind. It's even, I guess, to avoid gender bias or something like that, to say that females speak more. That's smart, very smart. Anyway, we're talking about males less than females, so we're gonna choose the less than symbol because the males came first. It's with respect to the males. So male less than female, that's where we choose the less than. Always choose the equal to for the H sub 0. And now the fun part, the test statistic stuff. So let's go ahead and put on the TI-84. Oh, and don't forget, whenever we get our hands on the p-value, when it's less than your sig level, you reject the null. When the p-value is greater than the sig level, you fail to reject the null. So let's just keep that in mind. Let's turn on this calculator. Okay, so what do we do? How do we use this data here? Okay, so it's a little bit different. The TI-84 would do most of the work. You just have to know what to do. So we're going to go to stats, and we're going to go to edit. And all right, that's old data from the last video. Let's just go ahead and delete that, or clear that, I should say. Don't hit the delete button, hit the clear button. Okay. Okay, so what's the first set of data? This is for the males. That's going to be 15499. We have 26878. We have 1386 7718 18141 15003 14491. Yeah, it's tedious, but yeah, you know how it is. All right, we're going to move over to the female row. So that'll be 24931 13536 18183 17569 12669 16738 16771 18137. Okay, so what do we do now? Well, in this section, we're dealing with mu sub d, right? That stands for difference. So basically, you have to figure out what is the difference between these two sets of data. And we're going to use the calculator to our advantage. Basically, you have to subtract everything from row 1 from row 2 to row 2. So basically, do row 1 minus row 2. Okay, so I know you don't want to sit there and do 15499 minus 24931. If you have the patience, I say go for it. I don't recommend it at all. You have a calculator, make the calculator do your work for you. So here's how you do it. Okay, so we're going to actually put all of our differences. Once we subtract them, we're going to put the answers inside of our L3. So to do it, you hit the up arrow. And it's asking, okay, what do you want L3 to be equal to? You can see at the bottom of the calculator screen. I want my L3 to equal to L1. So you hit the second key to get the blue letters on the face of the calculator, L1, minus, hit the second button again, L2. So you're going to subtract everything from, you're going to do L1, and then you're going to subtract L2. So you're subtracting L2 from L1. You can hit the down arrow, or you can hit enter. Let's hit enter. And look at that. If you were to do 15499 minus 24,931, you're going to get negative 9432. And this is all you need. We're going to focus on just the L3. We're going to get all of our statistics. And that's it. That's the only step you really have to worry about in this section. That's the only twist. And believe it or not, it's simple. So don't make the mistake of going to 2-sample-T test again like we did in the last video for independent samples. These are dependent samples, which means that we can combine the data by subtracting. All right, anyway, let's hit second quit. Remember, we're going to use L3 for all of our statistics. So hit stats. We're going to go over to test. And now, because we're only using L3, we're just going to narrow this down to a t-test. Now, you want to go to data because we input data. And remember, mu sub 0 is the claim number. In our case, the claim number is the 0 that's right here. You see mu sub d. We're going to just put a 0. Which list are we using? We're using L3. So yeah, typing in that is not going to work. We have to hit second and the 3 button to get the L3 dust right here. Bam. So it's going to calculate everything for us. Keep the frequency at 1. We're going to use the less than symbol like they did, or rather like we did, like we chose here. All right, hit calculate, and there goes all of our statistics. So what is the test statistic? The test statistic, you know it, it's going to be whatever the t is, that's negative 0.49. How many decimals? 2 decimals. So there we go. Well done. What is the p-value? P-value is right below it. They wanted 3 decimal places, so 0.319. Well done. Okay, what is the conclusion based on a hypothesis test? Well, let's compare our p-value. It's 0.319. It's less than 0.05. I'm sorry, it's greater than 0.05. So that's going to be a fail to reject. All right, so let's state that it's greater than that. It's greater than your sig level. We're going to fail to reject the null hypothesis. And whenever you fail to reject, there is not enough evidence to support the claim. So very consistent with the last couple of chapters that we've done. Stats test, because we're trying to figure out the confidence interval. So we need to go over to t interval. All right, we're going to go to data. On the list is L3. Now the C level, what's the C level here? As you may recall from the last couple sections, if we have 2 samples and if it's a left tail or right tail, you know, we're going to subtract that significance level twice. If it's a 2 tail, we only subtract it once. So remember, jot that little tidbit down in your notes somewhere because it's very important. What is our significance level here? It's going to be 0.05. So we do 1 minus 0.05 minus another 0.05. Hit enter, we get 0.9. Hit calculate. And there is our confidence interval. So we have negative 8510, and they said they wanted this n rounded to the nearest integer. So basically the nearest whole number. So over here we have 500, and now because we're rounding to the nearest whole number, the nearest integer, this is an 8, so we're going to add 1 to the ones place, so we get 5. Enter. There it is. Fantastic. Now, what feature of the confidence interval leads to the same conclusion reached in part A? Well, what was the conclusion in part A? We say we're going to fail to reject and that there is not enough evidence, right? So this confidence interval that we have here, we have a negative on the left and a positive on the right. So it does include 0. So it contains 0. And whenever it contains 0, we're going to fail to reject the null hypothesis. Yep. And so far, I guess they're not going to go too much into detail, but yeah, that's how you solve question number 2 for this case. And this is what we're going to keep doing. We're going to stick with this. The tricky part is when they do 1 tail and 2 tail and determining what is your sig level. So in the remainder of the video, just try to figure that out before we even get to it. Just ponder, what are we going to subtract twice, or we're going to just subtract once for our confidence level? All right, let's keep going. Okay, so for this example, we're talking about the freshman 15. Hopefully you guys haven't suffered through that, and hopefully you never will. All right, anyway, now let's go ahead and put the symbolic notation. We know that we're going to choose an equal to symbol right here, so let's get that out of the way. We're going to put 2 zeros because we're dealing with differences, the mean of the differences, standard deviation of the differences, all that good stuff. Now this part, it says, let's see, use a 0.01 sig level to test a claim that for the population of freshman male college students, the weights in September are less than the weights in the following April. So we're going to choose, you know, let's think about this for a second. Let's read more because it may not be quite apparent as to if we're going to use less than or greater than. Let's keep reading. It says, in this particular example, mu sub d is the mean value of the differences d for the populations of all pairs of data, where each individual difference d is defined as April weight minus the September weight. What are the null and alternative hypotheses for the hypotheses test? So this is April minus September. This is the future minus the past, right? Because in a school year, most people in school, you know, as soon as you graduate from high school, school starts back again in August, right? Or early September. So September will be considered the past, it will be considered the beginning, and then April is what comes after. It's the months following. So if we're trying to test a claim that September is less than April, which means that your weight at September is less than April, it's like decisions. Do we choose the less than or the greater than symbol? I'm going to show you something. Yeah, it's greater than. And the reason why we're choosing the greater than symbol is because we're talking about them, we're talking about the weight being less than September, right? So if the weight is less than September, that means that they're gaining weight, right? By the time they're in April, they're a lot bigger than what they were before. So the difference would be a positive difference. So we're going to choose the greater than symbol. If on the flip side, they said that your weight of September was greater than April, that means that you would have a negative difference. If you have a negative difference, that means that you actually lost weight, right? So look, if they ever give you this example, if they say September is less than April, like they give you that in the form of a claim, just choose the greater than symbol. You can write this down in your notes. I hate the word games that they play. Like it just sucks when they bring semantics into mathematics. It just ruins everything, in my opinion. But anyway, identify the test statistic. So we're going to go to stats. Let's go ahead and clear all the lists that we had. So clear list, and I want to get rid of L1, comma L2. You don't have to do this. You can go ahead and go in there individually and just hit the clear button over each of them. L3. All right, it is done. Remember, you don't have to do this. You can go to stats, you can go to edit, and if there was anything in here, like let's say a 9, you just go all the way to the tippy top, and you can hit clear and hit enter, and it'll do it for you. Okay. All right. So anyway, what do we have here? Go ahead and put everything for September, April, and yeah, let's go ahead and submit everything. So 60, 64, 71, 63, 75, 68, 62, 56, 54. All right, we're going to move over to the second row, 61. This is for April. 68, 69, 65, 82, 68, 65, 53, and 56. Okay, and remember, we need a third column for the differences between the two. So, are we doing L1 minus L2 or L2 minus L1? Well, we want that difference to be positive. We're trying to prove that, or we're trying to test a claim that in September you were less than April. So in April, you should be greater than September. So whichever one is the greater one should be the one you're inputting first. So basically, we're trying to do April minus September. And they even said it here. So it says the individual difference D is defined as April minus September, right? Isn't April L2 and isn't your September L1? So think of it that way. And that's exactly what we're going to do here. So I know it's a lot to take in, but just bear with me here. We're going to do second L2 minus second L1, all because they told us to subtract those two. So if they give you if they tell you exactly what to put in and give you in terms of this, like April weight minus the September weight, and that's what it's defined as, do whatever list that is corresponding to the other list. So L2 minus L1, hit enter. There goes the difference table that we're going to use. Let's make sure we exit out completely instead of just hitting the stats button. Because I don't know if you guys know, but sometimes when you hit the stats button, let's say here, it'll input crazy stuff inside of the inside of that list. So just to be safe, let's hit second quit. We're going to go to stats, test, and because we're t-test, and because we're only using L3, we're going to treat this as just one sample. So mu sub 0 is going to be 0. Keep that as 0. And this is for any mu sub d problem, okay, the difference problems. So let's go ahead and do that. We're going to go down, keep the frequency at 1. Okay, we're going to choose the greater than symbol, which we already have highlighted. Let's hit calculate. There it is. So our test statistic is going to be 1.53. All right, good job. P-value is right below it. So how many decimals? 3, so 0.082. Well done. Okay, the p-value is definitely greater than your sig level. So let's choose greater than. Whenever it's greater than, we fail to reject, or in other words, do not reject. And whenever we don't reject, there is not enough evidence. Okay, confidence interval. So stats, test. This is a T interval. And we have L3 in there. Leave that as 1. Now, what did we put here? If you recall from the last question, whenever, or the last chapter, the last section, I should say, for 9.2, technically this did come from a 2-sample data set, right? So, and it's a one-tail. So whenever you have a one-tail, remember the funny business? You subtract the significance level twice. Hit enter. So this corresponds to a 98% confidence level. Hit calculate. And there goes your confidence interval. Note that the left is negative, the right is positive, so it contains 0. So how many decimals? 1 decimal, so negative 1.4. And we have 4.5. Well done. Okay, what feature of the confidence interval leads to the same conclusion? Well, we're going to say we're not going to reject because that's what we have up here, right? We went through all of that work. Okay, because the confidence interval, and it includes 0. So whenever it includes 0, you want to make sure that you don't reject. All right, fantastic. More questions, huh? What do you conclude about the freshman 15 belief? So what did we just conclude? Go back up to here. We said that there is not sufficient evidence to support the claim that for the population of freshman male college students, the weights in September are less than the weights in the following April. So are we? I guess we're saying that we didn't gain weight, right? It says test the claim that the weights of September are less. So actually, it's the opposite. It's like we lost weight, us guys. Yoo-hoo guys, give it up for the guys. Sorry, females. Anyway, the test does not address the specific weight gain of 15 pounds. That is true, but it does suggest that there is, let me see. Yeah, there is no evidence or insufficient evidence, not enough evidence to conclude the males gained freshman year, the confidence interval. So does it contain 6.8 or not? No, it does not. Our confidence interval is between negative 1.4 and 4.5, right? So does it contain 6.8 kg? That is 15 pounds, right? And because they set it up here, it doesn't include it. So yeah, let's just put that down. All right, nice work. All right, next. Some of the stuff is a little self-explanatory. And you couldn't have gotten it right if you didn't get the right confidence interval. All right, anyway, all right, next. Let's see. Use a sample data with a 0.05 sig level to test the claim that for the population of ages of best actresses and best actors, the differences have a mean less than 0. Okay, so they told us what to put here for the symbolic notation. I guess no funny business this time. And for our difference D, it says it is defined as the actress's age minus the actor's age. So this is another female versus male thing. They're walking on thin ice here in 2021 because they're trying to do away with the whole male and female thing. Call me old school, but anyway, let's go ahead and do it. I don't want to put any political banter in this. Anyway. So let's go to stats, edit. Let's go ahead and clear everything. So we can hit clear. And let's just go down the line everywhere. Yeah, clear everything. Okay, everything is clear. So let's go ahead and put in our statistics. I'm sorry, not our statistics, our data. It's been a long day. 25, 28, 32, 27, 37, 24, 24 again, 45, 31, 34. And then on the right hand side, we're going to put the actors in year. So we have 65, 35, 33, 39, 27, 32, 56, 36, 40, and then 41. So, you know, we're going to start subtracting things. We're either going to do L1 minus L2 or L2 minus L1. Which one do we choose? L1 are the actresses. L2 are the actors. Actors sounds so weird to say. Actors. Anyway, so here's where they said it's defined as the actress's age minus the actor's age. So the actresses we used are L1, so it's going to be L1 minus the actors, L2. So it's second L1. All right, so second L1. Second L1 minus, hit the second button, L2. Hit enter, and yeah, that's what we're going to use. So let's hit second quit. Go to stats. We're going to go to tests. T-test. Data. That should be 0. That should be L3. We're going to use the same symbol that we use in our problem here. So H1, which is the alternative hypothesis. Hit calculate. And there it is. So your test statistic here is going to be whatever your T is, and it's negative this time. So this is negative 1.93. I'm sorry, 94. Excellent. What is the p-value? The p-value is 3 decimal places, so 0.042. All right, good job. Now the p-value is, let's compare it with the sig level. The p-value is actually less than our sig, right? 0.042 is less than 0.05. So is less than, which means we're going to reject the null. Whenever you reject, there is enough evidence. So let's hit enter. Okay, now the confidence interval. So let's hit stat. Go over to test. We're going to hit T interval. So right here at number 8. And let's see, L3, frequency. Okay, remember, don't just pass over this. Don't gloss over it. We have to figure out what that is. So this is a one-tail test. And remember, this technically came from 2 separate pieces of data. So this is a left tail test. Anytime you have a one tail test, whether it be left tail or right tail, you just do 1 minus, let me go over here, 1 minus the significance level twice. All right, that corresponds to 0.9 or 90% for our confidence level. And there it is. And notice that they're both negative. So because they both have the same sign on both sides, this is going to be a reject the null. So there is no difference. Shocking. So the confidence interval, 1 decimal place, let's see, 9. So negative 18.9. Over here we have negative 0.53. Hit enter. What did I do now? What did I do wrong? Oh, 1 decimal. I thought they were up to their shenanigans again. All right, let's just delete that little thing. We will never talk about this again. All right, well done. Okay, what feature of the confidence interval leads to the same conclusion reached from part A? Well, it does not contain any 0 because we didn't go from negative to positive. This is all negative, so it only includes negative. Okay, and whenever it only includes a specific sign, we're just going to reject. Make sure whatever you chose up here is down here, please. You don't want to miss out on those points. And there it is. Excellent. All right, moving right along. Okay, so use a 0.05 sig level to test the claim that there is no difference in height. So if there is no difference, we're not going to choose the less than, we're not going to choose the greater than, we're going to choose the does not equal to symbol here. So that's why we have this. So yeah, deductive reasoning. If they don't use the words less than or greater than, you're going to choose the equal to. So here's what we have now. Let's go ahead and get the test statistic stuff. Let's just ignore that. Okay, so because I do not want to enter all of these into my calculator, right? I'm going to show you guys how to use StatCrunch for this particular problem because these decimals are just killer. Okay, what is that about? I'm trying to go into StatCrunch here. Okay, that was weird. All right, let me go ahead and, oh, you guys can see the StatCrunch. Great. Okay, so now I want to find the difference table. And I want to find my mean and standard deviation. Once I have that, we're good. So it says stats, t-stats for paired because they're dependent upon each other. Now, okay, so be very careful. I think they're going to do, yeah, they're doing M1 minus M2. So depending on what they want, that's what we're going to put. So let's go ahead and read what they want us to, what do they, define it as. It says each individual difference D is defined as daughter's height minus mother. So daughter is M2. Well, no, daughter minus mother. So it's always first minus second. So daughter, our daughter data set is going to be our M1. And we want to subtract the mother, which is M2. So M1 minus M2. So daughter minus mother. They want you to put M1 minus M2 here. So make sure we put the daughter first. Daughter. Sample 2 will be mother. We're going to save the differences. Yeah, everything here is the same. And who knows, maybe they'll be nice enough to give us the statistics and everything like that. I'm going to put summary statistics too. Why not? Compute. Okay, so you can see we have everything here. If we move this away, they actually gave us, can we make this smaller? Yeah, they actually gave us a data set, a set of data. So just in case this doesn't work, we're just gonna run to our trusty TI-84 and just use that. But anyway, we have some statistics going on. We came here for the test statistic and the p-value. So let's see if this darn thing is going to work. I don't, just like in the last video, I don't trust the StatCrunch. I'm not familiar with it like that. Where are we? Yeah, we're here. Okay, test statistic. What is our test statistic? 2.07. 2 decimal places, yeah, 2.07. Oh, it worked. What do you know? P-value, 3 decimal places, 0.068. Will it work? It does. Haha, very good. Okay, so our p-value, which is 0.068. Where's our significance level? There it is, 0.05. 0.06 is greater than 0.05, so this is a fail to reject. So it's greater than a sig. We're going to fail to reject that null, and there is not enough evidence. All right, nice work. That's it? Oh, come on. No, they're no fun. Okay. Yeah, very good. Very good. All right, so anyway, let's go ahead and figure this one out. Looks like they only want the confidence interval. And they told us that they want a 95% confidence interval. So it's saying construct a 95% confidence interval for the mean of the before and after differences. Well, did they at least tell us which one comes first? So a study was conducted, blah, 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 reducing pain. The measurements are centimeters in a pain. Assume that the pair sample data are sample random, that's good, and that the differences have a distribution that is approximately normal. Construct a 95% confidence interval for the mean of the before and after differences. Now, they didn't tell us which one is which. So, this is a before and after type deal. I'll tell you what, we're just gonna input the data and we're gonna see if we get it right the first time, because they didn't quite define it. There were times when we did L1 minus L2. Let's see if they even care what the. Yeah, this is a little trial and error for me. Let's go ahead and just put everything in. Let's clear everything. Okay, so we have 4.6, 2.6, 7.3, 12.2, 9.6, 7.1, 7.3, 0.4. All right, over here, 6.5, 2.5, 7.4, 8.6, 8.8, 6.5, 3.9, and 2.3. So the question here was, are we supposed to do before minus after or after minus before? We're gonna try both and try to make some sense of this. So I'm gonna do L1 minus L2 just randomly, and I hate to say that, but I'm not gonna lie, I'm not 100% confident. I don't have a great confidence interval of how well I know this chapter, but we'll get to the bottom of it and we'll get you an A. All right, so L1 minus L2. Yep, there goes our difference. So let's quit from here. Stats, tests, t-test. We're gonna go all the way down to L3. I'm sorry, not t-test. Force of habit, sorry. Stats, test. We're finding a confidence interval. So this is a t-interval. T-interval. And they were nice enough to tell us the confidence interval. So we're going to choose 0.95 because they told that to us here. So 0.95, hit calculate. And let's see if we get it right. So 2 decimal places, this is negative 1.16. And we have 2.2 decimal places, 3.1. Let's see if we get it right. We got it right. So I'm curious. I'm curious if, well, we'll go back in a second. Let's answer this. Does hypnotism appear to be effective? You see, I didn't even read this. I should have read this. Does hypnotism appears to be effective in reducing pain? Well, if you recall, we have a negative value and a positive value. It includes 0. So whenever it includes 0, that means that there is no difference. So does it appear to be effective in reducing pain? No, because it includes 0. That means that there is no difference. So take a look. It includes 0 because we have a negative, we have a positive. So definitely 0 is in between a negative and a positive number, right? So it's either going to be A or C. So does it appear to be effective? No. Yeah, hypnotism doesn't work apparently. Well, in this case, I'm pretty sure there may be other statistical cases depending on what you choose for your confidence interval. Before we go to the next question, I want to see if we get the same answer by, instead of doing L1 minus L2, we do L2 minus L1. I think this is a question that we all want to know. So let's do L2 minus L1, because if it doesn't matter for confidence intervals, that'll be great for us. They didn't define it. So we're doing L2 minus L1 this time. So let's go to stats, tests, not t-test, but t-interval. Hit enter. We're choosing 95. Calculate. And we get negative. Yeah, it's completely different. So for this particular question, and I wish I had more insight into this, but for this particular question, If they don't define it for you, you're going to choose L1 minus L2 every time if they don't define it. Because you can see they give us two different answers. That sucks, but it's whatever. All right, anyway, let's go ahead and continue. Okay, so question 7. So for the symbolic notation, let's just go straight to there. Let me see. The measure height's going to be, let's see, use the 0.10 sig level to test the claim that for females, the measured heights tend to be higher than the reported weights. So let's see what they're talking about. So here's the set of data. And we have reported, and then we have measured. So they want us to test the claim that for females, measured is higher than reported. So measure is higher than reported. That means that there should be a positive difference. So that means that this is going to be greater than. Okay. I know it's so weird. So whenever they, let's see, measure heights tend to be, yeah, whenever the second is larger than the first, we choose greater than for a positive difference. If it was less than, it'll be a negative difference. Take the best notes you can. Maybe ask your professors for clarification. Hopefully they'll get back to you. Hopefully they wrote some notes somewhere. They should be teaching you guys these things. Yeah, so I'm not technically a teacher, just a little disclaimer. I'm just to help, just a supplementary, I guess, tutor, I guess. I'm still awesome. Anyway, let's go to StatCrunch. I'm not going to put all of these values into my calculator. No way. My calculator will hate me for that. It's a machine. Machines have feelings too. All right, we're going to go over to StatCrunch. Okay, so we're in StatCrunch right now. Let's see. Are we doing top minus bottom or bottom minus left? That's a good question. Well, let's see if they were nice enough. And it sucks when we have to depend on their kindness. But let's see if they define anything for us. And it looks like they did. This is defined as measured height minus reported weight. So measured minus reported. So we're going to write the measured first. So let's go to stats, paired. This is measured minus reported. So we're basically saying that measured is your M1 and reported is your M2. Okay, we're looking for the test statistic stuff. Let's go ahead and write the differences just in case we're not able to get the correct answer. We're going to check that box, so it'll give that to us. If anything goes haywire, we're going to put it in our TI-84, but it was acting pretty nice last time, so let's see. We're going to choose the greater than symbol. So you can either do a confidence interval or you can do a hypothesis test. We're doing the hypothesis test right now. So we're going to choose hypothesis test, which means there's no need to choose that because this isn't checked. All right. Yeah, let's go ahead and compute. And here is our statistics. Okay, so just making sure that you can see. So we have t equals, they wanted 2 decimal places, so 1.71. Nice work. P-value, 3 decimals, 0.045. Good job. The p-value, let's compare it with our sig level. The p-value is less than 0.1, so 0.045 is less than 0.1, 0.10, right? So it's less than, which means we're going to reject. And whenever you reject, there is enough evidence. Nice work. Okay, confidence interval. So we're going to go back to StatCrunch. We're going to hit stat. We're going to go to t-stats because we don't know the population standard deviation. All right, paired. So remember, we're doing measured minus reported. Let's just double check that that's what they said. Yeah, it's defined as measured minus reported. So we're going to go here, measured minus reported. We don't have to save differences again. This time we're choosing a confidence interval. And this is a 2-tailed test, so we're going to subtract that that sig level twice. So this is 0.10. So we do 1 minus 0.10 minus another 0.10. That's going to be 0.80, and you can use this in your calculator. So 1 minus 0.1 minus another 0.1 is 0.8. All right, and I think that's all we need. Let's hit compute. So we came here for L limit, which stands for lower, and U limit, which stands for upper limit. And let's go ahead and let's hope they're going to be generous. It sucks counting on the generosity of a program, but we're all going to be at the mercy of computers someday. Kind of are. Anyway, 0 point. Let's see how many decimals. 2 decimals, so 32. Over here is going to be 2.24. Nice work. What feature of the confidence interval leads to the same conclusion? All right, well, let's go ahead and put the same conclusion down. We're going to reject, and we're rejecting because it's only positive values here. We have a positive here on the left and a positive here on the right. So, sorry about that. Only positive values. Well done. More crap. Okay, for a simple random sample of size n equals 0, from the 127 measured and reported weights, the calculated p-value was 0.385, and the 80% confidence interval was between here and here, negative 1.44 and positive 2.0. Oh, that includes 0, so that's a fail to reject. Did the larger data set have much effect on the results? Yeah, because now this sucker is including 0. So the larger data set caused the p-value to... All right, so let's compare our p-value, which is 0.045, with their p-value, which is 0.385. So ours is actually less than 0.385, right? So the p-value actually increased in a conclusion. And now let's take this p-value and compare it with the sig level. So 0.385, let's compare it to 0.1. Is greater than. So this is going to be a fail to reject. Yep. So we're going to change from reject to do not reject. Uh-oh. Uh-oh. What did I do? What did I do? The larger data set caused the p-value to 0.04. This is, yeah, it increased. What did I do? Okay, only positive values, so we reject. Okay, this includes 0. The larger data set caused the p-value to, yeah, our p-value here is 0.04. The p-value here they have here is 0.38. It increased. Yeah, the larger data set caused the p-value to increase in a conclusion to from reject to do not reject. Yeah, what the hell is going on? What the hell? Give me 1 second here. We're gonna, it's just to get one wrong after we're on such a little roll, a nice little roll. Stay reject. Review the conclusions of the blah, 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 value. Yeah, I know that. I think something's wrong here. Something's going on. The p-value. They can't be talking about the p-value. Oh, wait, no. Calculated p-value is 0.385. What the hell? Can't be decreased. Wait, p-value to stay constant? 0.0. What? No. Nah, no way. Yeah, we're going to get this wrong, guys. Sorry. Okay, so let's see. The correct answer is changed from do not reject to reject. Huh? Didn't we have reject here? And this is the crap I'm talking about. I'm going to go back and fix this one. Learn from, I guess, my mistake. Even though I call shenanigans on this. Why? The conclusion. Are they not talking about the conclusion from here? So silly. Anyway, hate that. Sucks that you guys had to see that. Anyway, the last one. And I'm just not feeling it no more. I apologize. I hate getting questions wrong for stupidness. Maybe they'll explain that to us later. Use a 0.10 to assess a claim and it tends to be younger. Okay, they already defined everything. If they ask us more nonsense like that, I'm going to choose the opposite of the right answer, basically. And that's just so lame. That's not the way mathematics is supposed to be. But it's whatever. Okay, it's defined as actor's age minus the actress's. Anyway, I'm so bummed out by that last one. Maybe someday I will understand it. Hopefully you understand it. If remember, ask your professor or something, look in the notes. Your professor should have provided you with everything you needed ideally, right? But we know that's not the case. Anyway, maybe I'll make another video explaining their logic. All right, have everything here paired. Sorry to sound like such a downer right now. I hate it. All right, anyway, which one comes first? If it's greater than, let's see, it's defined as actor's age minus actresses. So actors come first, then actress. Actor, then actress. Yeah, we know everything is going to work. Let's choose greater than. And yeah, hit compute. Yeah, so there goes the test statistic. So 6.2. And the p-value is going to be less than 0.0001. So that's just 0, blah, blah, blah. Blah, blah, blah. The p-value is less than a sig. Let's see the nonsense. So we're going to reject, and there is sufficient evidence. Yeah, you know it. I'm just so turned off. Confidence interval, we're going to go over here. We're going to go to stats. We're going to go to paired. Once again, it's going to be actors minus actresses. So actors come first. Then the actresses. Then we're going to go here. So one tail test. So we're going to subtract the significance level twice. The sig level is 0.1. So subtract it twice. You get 1 minus 0.1 minus 0.1. You're going to get 0.8. And yeah. Hit compute. There's a lower and there's the upper. It's only containing positive values. And blah, 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 blah. And now we have reached the lame part of statistics. So 1 decimal, this is 7.5, 11.4. Well done, blah, blah, blah. Let's see, what feature does confidence, whatever. I'm going to choose the same thing and reject. And it only includes positive values. Oh, they're not going to ask us the other crap? All right, whatever. All right, so that's the end of this video. You can go to the next video or review stuff from the last. For you guys that want to see me get the 100%, you can stick around. I got some unfinished business with that one. I'm going to go back. And what the hell? Come on, man. So not cool. So the larger data set caused the p-value to decrease, huh? Even though it was at 0.045. Am I missing something here? Am I tripping? Because they marked us right for this 0.045, and it's supposed to be compared against this, right? Let me see. Maybe I'm missing something. For a simple random sample of size n equals 10 from the 127 measured and reported weights, the calculated p-value is 0.385. And the 80% confidence interval was between here and here. Did the larger data set have much an effect on the results? Well, which one is the larger data set? How many numbers do we have here? A lot. I guess so. N equals 10. Yeah, that's not from here. Let me see. Okay, so definitely... So it's not referring to this one. So, Oh, okay. So this is, I guess this is past tense. This is what they did at first. And then they went around and changed it to what we got here. So it would have been do not reject. Oh, that's tricky. Those bastards. Excuse my language. Man. So the p-value did increase when you go from here. I'm sorry, did decrease when you go from here to here. So once again, thank you guys for watching. I'm going to go ahead and hit similar question with a bunch of sarcasm. So you might want to just leave the video now and go to the next one if you haven't already, or you can stay for the toxicity. And yeah, this is me, Salty. So this is a Salty speed run here. Let's go ahead and go to Stack Crunch. Stupid Stack Crunch. Okay, we're gonna go over to data. We're gonna go over to, I'm sorry, stupid stats. We're gonna go over to stupid T stats. And which one comes first? Oh, first of all, let's go ahead and put the correct answers here. Yeah, this is gonna be me being very sloppy, more sloppy than usual, actually. Okay, so this is gonna be a stupid equal sign with a stupid 0. Once again, please exit the video if you don't want to see the side of me. As a matter of fact, okay. Higher, right? So they say higher, so I'm just gonna choose greater than just for the hell of it. Yeah, higher, greater than, whatever, blah, blah, blah. Test statistic. Our test statistic is going to be whatever this stupid Stack Crunch thing gives us. So what was it defined as? Measured weight minus reported. So measured minus reported. So measured minus reported. Stupid. Okay, so we have stupid greater than, and there are more things I really want to say right now because I can't curse like a sailor when I'm pissed off enough. But I'm not that pissed off. It's not like I stumped my toe. If I was in pain, only my pride is in pain right now. I guess it's worse. Okay, anyway. Yeah, there goes our stupid statistics, hopefully. So we have 3.31. And we have stupid ass p-value, 0.00. 3 decimals, 001. Freaking. This is how this class is laid out. You know, you, like, now that I know what the right answer is, you can go back and get your points. If they throw it in an exam, you'll be ready for that crap. Since the p-value is less than the sig level, we're gonna reject, and there is, okay, yeah, we know it. Anyway, let's go ahead and find the confidence interval. Go to stats, go to T, go to pair, blah 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 blah. We're gonna go to measured minus reported because that's what they defined it as. Going to choose the confidence interval. This was 0.1, so we're going to do 1 minus 0.1 minus 0.1, so that's 0.8. Stupid 0.8. Stupid complicated statistics. Anyway, so salty, man. Hopefully I'll be chipper in the next video. I think I will. Unless this happens again, and I'm like, Okay, lower limit is 2.2 decimal places, 2.08. And this is 4.73. Good job, my ass. Oh, excuse me. Let's see what featured. Okay, it only includes positive. Yes, I know I have a 99 on this thing, but it doesn't. I still don't like it. We're going to agree whatever we had before. Blah, 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 blah. Okay, the larger decrease. Yeah, whatever. Goodbye. Thanks for watching. Freaking.